So this is Quadratic Equations Part 4, part of Class 11 syllabus Mathematics ISC. Here you will practice more problems on sum and difference of roots of a quadratic equation. Now two candidates attempt to solve a quadratic equation of the form x squared plus px plus q equal to 0. One starts with a wrong value of p and finds the roots to be 2 and 6. The other starts with a wrong value of q and finds the roots to be 2 and 9 and minus 9. Find the correct roots and the equation. Now you have the equation is x squared plus px plus q equal to 0. The roots are 2 and 6. So by our formula x squared minus sum of the roots into x plus product of the roots equal to 0, you get x squared minus 8x plus 12 equal to 0. Now q is 12 because the value of p is wrong. And in the second case, the roots are 2 and minus 9. So using the formula x squared minus sum of the roots, I get x squared plus 7x plus product of the roots, I get minus 18 equal to 0. So p is 7 and q is wrong here. So your correct equation is x squared plus 7x plus 12 equal to 0. Factorizing it, you get x plus 3 into x plus 4 equal to 0. So your roots are minus 3 and minus 4. Next question. Alpha, beta are the roots of x squared equal to 7x plus 4. Show that alpha cubed equal to 53 alpha plus 28. Find alpha by beta plus beta by alpha. So we have alpha is a root, so I have alpha squared equal to 7 alpha plus 4. Now we need to find alpha cubed plus something. So alpha cubed is basically alpha squared into alpha. That is 7 alpha plus 4 into alpha. So that alpha cubed will be 7 alpha squared plus 4 alpha, that is 7 into, again you substitute for alpha squared, which is 7 alpha plus 4. So alpha cubed will be 53 alpha plus 2 alpha. And x cubed, you have to find the roots. Going back to the question, you have to show that alpha by beta, find alpha by beta plus beta by alpha. So alpha plus beta will be minus b by a, which is 7. Alpha into beta is c by a, which is minus 4. So alpha by beta plus beta by alpha will give you alpha squared plus beta squared by alpha beta. That is alpha plus beta the whole squared minus 2 alpha beta, that is alpha squared plus beta squared. Substituting for alpha plus beta and alpha beta, you get alpha squared plus beta squared is 57. So I have alpha plus beta by alpha will be minus 57 by 4 because alpha beta is minus 4. We are basically making use of this fact. Now if alpha and beta are the roots of a quadratic equation, then how do you write the equation? X squared minus sum of the roots into x plus product of the roots equal to 0. So now we will be solving problems based on this topic. So form an equation whose roots are 3 and minus 1 by 3. So that will be x squared minus sum of the roots is 3 minus 1 by 3 into x, and product of the roots is 3 into minus 1 by 3. So that is minus 1. So your equation is x squared minus 8 by 3x minus 1 equal to 0, or 3x squared minus 8x minus 3 equal to 0. Now form an equation with rational coefficients, one of whose roots is root 3 plus 1 by root 3 minus 1. So if one root of a quadratic equation is a plus root b, the other root is a minus root b. This is something you need to remember. So you have root 3 plus 1 by root 3 minus 1. When I rationalize, you multiply and divide by root 3 plus 1. So I get root 3 plus 1 the whole squared by a minus b into a plus b, that is 2. So you get 3 plus 1 plus 2 root 3 by 2. That will give you 2 plus root 3. So the two roots are 2 plus root 3 and 2 minus root 3, because as I said before, if one root is a plus root b, the other root is a minus root b. So sum of the roots is 4 and product of the roots is 4 minus 3, which is 1. So your equation will be x squared minus sum is 4x plus product of the roots is 1, which is equal to 0. Next question, if alpha beta are the roots of ax squared plus bx plus c equal to 0, form an equation whose roots are 2 alpha, 2 beta, alpha plus k, beta plus k. So alpha plus beta is minus b by a, alpha into beta is c by a. So 2 alpha plus 2 beta is 2 into alpha plus beta, that is minus 2 into b by a. Product of the roots is 2 alpha into 2 beta, that is 4 alpha beta, which is 4c by a. So your equation will be x squared minus sum of the roots is minus 2b by a. So I get plus 2b by ax plus 4c by a equal to 0. That will give you ax squared plus 2bx plus 4c equal to 0. And sum of the roots when it is alpha plus k and beta plus k will be alpha plus k plus beta plus k, that is alpha plus beta plus 2k, that is minus b by a plus 2k, which is minus b plus 2ak by a. And product is alpha plus k into beta plus k, that is alpha beta plus k into alpha plus beta plus k squared, that is c by a plus k into minus b by a plus k squared, that is ak squared minus bk plus c by a. So your equation will be x squared minus b plus 2ak by a into x plus the product is ak squared minus bk plus c by a equal to 0. So when you take the LCM, you get ax squared minus of 2ak minus b into x plus ak squared minus bk plus c equal to 0. Next question, if alpha beta are the roots of 2x squared minus 3x plus 1 equal to 0, form an equation whose roots are alpha by 2 beta plus 3, beta by 2 alpha plus 3. So alpha plus beta will be minus v by a, which is 3 by 2. Alpha into beta is c by a, which is half. So alpha by 2 beta plus 3 plus beta by 2 alpha plus 3 will give you alpha into 2 alpha plus 3 plus beta into 2 beta plus 3 by the LCM is 2 alpha plus 3 into 2 beta plus 3. That will give you 2 alpha squared plus 3 alpha plus 2 beta squared plus 3 beta by 4 alpha beta plus 6 into alpha plus beta plus 9. That is 2 into alpha squared plus beta squared plus 3 into alpha plus beta by 4 alpha beta plus 6 into alpha plus beta plus 9. Now we need to find alpha squared plus beta squared, that is alpha plus beta the whole squared minus 2 alpha beta. Alpha plus beta is 3 by 2, so alpha plus beta the whole squared is 9 by 4, minus 2 into alpha beta is half, so you get 5 by 4. So substituting here you get 2 into 5 by 4 plus 3 into 3 by 2 by 4 into half plus 6 into 3 by 2 plus 9, which is 7 by 20. This is the sum of the roots. And product will be alpha by 2 alpha plus 3 into beta by 2 beta plus 3, that is alpha beta by 4 alpha beta plus 6 into alpha plus beta plus 9. So when you substitute, you get it as half by 4 into half, that is 2 plus 6 into 3 by 2 plus 9, which is 1 by 40. So your equation is x squared minus 7 by 20x plus 1 by 40 equal to 0, or 40x squared minus 14x plus 1 equal to 0. Next question, if alpha beta are the roots of 2x squared minus x plus 3 equal to 0, form an equation whose roots are alpha minus 2 and beta minus 2. So again we are using the same thing, alpha plus beta is minus b by a, which is half, alpha into beta is c by a, which is 3 by 2. So your sum is alpha minus 2 plus beta minus 2, that is alpha plus beta minus 4, which is half minus 4, which is minus 7 by 2. And product is alpha minus 2 into beta minus 2, that is alpha beta minus 2 into alpha plus beta plus 4, that is 3 by 2 minus 2 into half plus 4, which is 9 by 2. So your equation is x squared plus 7 by 2x plus 9 by 2 equal to 0, or 2x squared plus 7x plus 9 equal to 0. Next question, the ratio of the roots of x squared plus alpha x plus alpha plus 2 equal to 0 is 2. Find alpha. So let the roots be m and 2m because the ratio is 2. So m plus 2m will be minus b by a, that is minus alpha. M into 2m is 2m squared is alpha plus 2. Now from here 3m is minus alpha, or m is minus alpha by 3. Substitute this value of m in this equation. So you get 2 into alpha squared by 9 is alpha plus 2. You get a quadratic, that is 2 alpha squared minus 9 alpha minus 18 equal to 0. You can factorize it into 2 alpha squared minus 12 alpha plus 3 alpha minus 18 equal to 0. So you get alpha minus 6 into 2 alpha plus 3 equal to 0. So alpha is 6 or minus 3 by 2. Now next question, if r is the ratio of the roots of ax squared plus bx plus c equal to 0, show that r plus 1 the whole squared into ac is b squared r. So let the roots be alpha and alpha r. So I get alpha plus alpha r is minus b by a. Alpha into alpha r, that is alpha squared r is c by a. Take out alpha here. So I get alpha into 1 plus r is minus b by a, or alpha is minus b by a into 1 plus r. Substitute here. So I get minus b by a into 1 plus r the whole squared into r is c by a. Cross multiply, so I get b squared by a squared into 1 plus r the whole squared into r is c by a, or b squared r is ca into 1 plus r the whole squared. Next, find the condition that one of the roots of ax squared plus bx plus c equal to 0 may be reciprocal of the other, negative of the other, and twice the other. So if the roots are reciprocal of each other, they will be alpha and 1 by alpha. So alpha into 1 by alpha is c by a, or c equal to a. If the roots are negative of each other, the roots will be alpha and minus alpha. So alpha minus alpha is minus b by a, that means b equal to 0. And if one root is twice the other, let the roots be alpha and 2 alpha. So alpha plus 2 alpha is minus b by a. Or 3 alpha is minus b by a, so alpha is minus b by 3a. Now 2 alpha squared is c by a, because that is a product of the roots. So substituting alpha as minus b by 3a here, you get 2b squared by 9a squared is c by a, or 2b squared equal to 9ac. So genius is nothing but an uncommon aptitude for perseverance. So take a pen and paper and practice each slide, each step along with me. And my next video will be next week, which will be on more about nature of roots of a quadratic equation. Thank you.